This is the second video on inequality, so if you haven't watched the first one, you should do that. Because in this one, I'm just going to talk about a specific type of question that you might see on the test where x is bounded on both sides by numbers, and you have to either find the interval or maybe find whole numbers that x can equal. So for example, a simple problem would be x is greater than 4 and x is less than 7. And so if we are looking at a number line, so this is a number line, 0, 1, 2, 3, 4, 5, 6, 7, 8. So here x is greater than 4, so it's not greater than or equal to, so it can't equal 4, so it's greater than 4. So we put an open circle on the 4. If it was greater than or equal to, we would fill that in, indicating that it could also equal 4. But this is showing that it's bounded on the left-hand side by 4. On the right-hand side, it's bounded by 7. Again, it can't equal 7, so we're going to put an open circle. But x can equal any number in between 4 and 7. So if the question is asking for whole numbers, remember those are basically integers, or they don't have any sort of a decimal or fractional part to them. The whole numbers that satisfy this would be x can equal 5 and x can equal 6. Those are the only two whole numbers inside that interval. So this would be the answer. X can equal 5 or x can equal 6. Either one of those satisfy this equation where x is greater than 4 and x is less than 7. So when you see it bounded, the x bounded on both sides, you have to read that as an and statement. You have the left-hand side says x is greater than 4 and x is less than 7. So it's really kind of two inequalities that you have to figure out the actual answer to the question. So we're going to do an equation that's a little bit more complicated. Find the whole number values or interval for x. And so now your questions, a lot of them are going to be multiple choice. So if we give a multiple choice, so here your first choice is -1 to 3. Second choice is -3 and -2. Next choice, -3 to -1. And the last choice is -2 and -1. The question is going to be -3 less than or equal to 3x plus 2, which is less than 3. So here we have x in the middle. It's bounded on each side. So we have to solve this side, and we also have to solve this side, and our value of x has to satisfy both of those. So the first thing we're going to look at is just the left-hand inequality, where we have -3 is less than or equal to 3 times x plus 2. And we're going to solve that for x. So it's really just a basic algebra problem. If you watched the first video, you know that we're just going to treat this essentially like an equal sign. So here we have the distributive property. If you don't know what the distributive property is, you need to watch the video on mathematical properties. So we're first just going to distribute this. So you have -3 is less than 3x plus 6. It's 3 times x plus 3 times 2. Now we're going to solve for x. We need to get rid of the 6, so we're going to subtract 6 from each side. And we end up with -9 is less than or equal to 3x. We need to get rid of the 3, So we're going to divide by 3 on each side. Since we're dividing by a positive number, we don't need to do anything with the sign. So we have negative 3 is less than or equal to x. So x is greater than or equal to negative 3. That will satisfy that side of the equation, but that's only half of it. Because remember, we also have to satisfy this part of the equation, or the inequality, I should say. So now we're just going to look at this side. And we have 3 times x plus 2 is less than 3. Again, we're going to use the distributive property. 3x plus 6 is less than 3. We need to get rid of the 6. 3x plus 6 minus 6 is less than 3 minus 6. If you don't know how to solve this algebra problem, you need to watch the videos on solving basic algebra problems. So we have 3x. 3 minus 6 is negative 3. Now we need to get rid of the 3, so we're going to divide by 3. We're dividing by a positive number, so we don't need to do anything with the sign. So we have x is less than negative 1. So if we put this all together, we have x is greater than or equal to negative 3 and x is less than negative 1. If we were looking at a number line, this was negative 4, negative 3, negative 2, negative 1, 0, 1. This is just our normal number line. It says x is greater than or equal to negative 3, so that's a solid dot we're going to put there, and it's less than negative 1. So it's not equal to negative 1, it's less than negative 1. So we're going to put an open circle there. So x can equal any of these numbers between negative 1, less than negative 1, and equal to or greater than negative 3. So we go back here. Remember, it says find the whole numbers, so not the fractional or decimal numbers. Find the whole numbers or the interval for x. So this is our answer. So A, negative 1 to 3. Well, that would be out here, right? It's not negative 1 to 3. It's negative 3 to negative 1. So that's not a right answer. B is negative 3 and negative 2, meaning those are the two whole numbers that fit. Negative 3, well, that fits because x can equal negative 3 and negative 2. So this actually is the right answer, but we'll look at the last two as well. Negative 3 to negative 1, that means it's the interval negative 3 to negative 1. But because it can't equal 1, this is a less than negative 1. It can't equal negative 1. This is not a right answer either, because this is saying that it can equal negative 3 and it can equal negative 1, and it can't. Only if this was a less than or equal to sign, but it's not a less than or equal to sign. And the last one, negative 2 and negative 1, meaning that those are the two whole number values. Well, negative 2 is right, but negative 1 doesn't satisfy this equation because negative 1 is not less than negative 1. It's equal to negative 1. So that's not a right answer. So the correct answer is the two whole numbers are negative 3 and negative 2. So when you see a problem like this, you basically break it up into two parts. Solve for x like you would any other algebra problem, but you have to put them together at the end because it's like an and statement. It has to satisfy this and it has to satisfy that.